Assalamualaikum. So today I'm going to do the lab for the calculate IPv4 subnets. So for the objective, the part 1 is to determine the IPv4 address subnetting. For the part 2 is to calculate IPv4 address subnetting. So for the background, it's the ability to work with IPv4 subnets and determine network and host information based on the given IP address and subnet mask is critical to understanding how IPv4 networks operate. The first part is designed to reinforce how to compute network IP address information from a given IP address and subnet mask. When given an IP address and subnet mask, you will able to determine other information about the subnet. So what you need for this lab is one PC, and the optional one is IPv4 address calculator. So for the instructions said that fill out the tables below with appropriate answer given the IPv4 address, original subnet mask, and new subnet mask. So this is what we've given: host IP address here, original subnet mask here, and the new subnet mask here. So first of all, first question is said that the number of subnet bits. So to find this, we need to find the prefix from the new subnet mask and the prefix from the original subnet mask. So to find this, see for the new subnet mask is 224 at the end. Subnet mask 224. So the prefix is 27 and the original is 24. So what we have was 27 minus with 24. So the answer we have is 3. Okay, so for the next question is number of subnets created. So to find this, we just need to multiply 2 with the power of the number of subnet bits, which is the answer that we have distance. So it is 2 to the power of 3 is equal to 8. Okay, so next is number of host bits per subnet. So what we need to do is we need to find the prefix for the new subnet mask and minus it with 32. So what we have here is 27 minus with 27. So we get 5. So the answer will be 5. So next one is number of hosts per subnet. So same as this one is 2 to the power of the number of hosts bit per subnet, which is we have done this here before. So to change it to 5 and minus it with 2, which is the 2 is represent for the network address and broadcast address, which is we're not going to calculate them onto this equation. So what we have here is 2 to the power of 5 and minus it with 2, and then we got 30. Let's put a bracket here first. Alright. So next one is network address of this subnet. So for this one, so for the network address, let's go to here. So first of all, we need to fill in the IP address. So IP address is 91.192.168.200 and 139. Then we need to change it into binary. 39 is 1000 1011. So 200. So 100 111 001 0 0 0 168. Get 1 0 1 0 1 0 1 0 1 0 1 0 0 0. So 192. Get 1 1 and then all 0. So 1 1 0 0 0 0 0 0. So the next part is we need to put a subnet mask. So for the subnet mask, we need to put a new subnet mask. So 255, 255, 255, and 224. 255, 255, 255, and 224. Right. Yes. So this is easy one. So you put 1, 1, 1, 1, 1, 1. So for the 224, 1, 1, 0, 0, 0, 0, 0. Okay. So after changing them, both of them to binary, we need to copy this one. Copy the binary for the IP address and put right here. And copy this one, subnet mask binary, and then paste it right here. So after paste that, what we need to do is to multiply both of them, the IP address and subnet mask. So we know that whatever is multiplied with 1, this will get the same answer as top. So we just need to copy this and put it right here to this one, and then everything that multiplied with 0 will become 0. So like this. So what we need to do is change the binary into decimal back. So here will be 192, 168, 200, and for the binary 100. So 7. So we get 1. You get 64. Oh no, it's not. I'll have to calculate it. So what you get here, we got 128 right here. So 128 times 1, and so we got 128 here. So that's is our network address, which is 192.168 and 200. Oh, 128. So for the next one is how to find the broadcast address. So same again, like this one. So what we need to do is just multiply it until right here. So we will get the same answer. Anything multiplied with 1, we get the same answer. So what we get here. And then for the rest of this, usually we need to multiply with 0, but now we just fill in with 1. So we got 1 there. So and then we just change them into the decimal. So we got 192, 168, 200, and then so we got 128 right here. So 128 plus with 16, 8, 4, 2, and 1. So we got 159, right? So this is our broadcast address. So just here. So for the IPv4 address for the first host of the subnet, we need to pick the one next to the network address, which is after 128, we will get 129. So do is 1292.168.200 and 129. And for the IPv4 address of last host on the subnet is 1 before the broadcast address. So before the broadcast address is 158. So let's put it 192.168. 200 and 158. So that's for the first problem. So next on to the problem 2, the number of subnet bits, same as the top. To find the prefix of this and minus with this prefix. So 255, 255 and 128. So 128 is 17. So wait. So 17 minus with the 255 is 8. So it's 8, we get 9. So this for the number of subnet created is 2 to the power of 9. So we should get 9 is 512. So for the number of host bit per subnet is that leads to minus the 32 is with the prefix of the new subnet mask, which is this. So 17. So 32 is minus with 17, which will get 2 minus with 17 is 15. So 15. And for the number of hosts per subnet, which is bracket 2 to the power of 15, power of the number of host bit per subnet, and we minus it with 2, which 2 once again is representative for the network address and broadcast address. So 2 to the power of 15 is minus with 2, should get 32,766. So for the network address for the subnet, so again, go to this, clear this one, this. So we need to put the IP address first. So the IP address is 10.101, 10.101, 99, 2899 and 228. So we need to change it into the binary. So what to do is change it. Then we get 10, 10, and then 0, 0, 0, 0, 1, 3, 4, 5, 6, 7, 0, 1, 1, 0, 0, 1, 0, 1. 1499, change it to binary, we get 3, 4, 5, 6, 7, 8. So 0, 1, 1, 0, 0, 0, 0, 0, 1, 1. For the 228, got 3, 1 to 3, 2, 1, and 0, 0. So this is for the binary for the IP address, and then we need to take the subnet mask. 255, 55, 128, and 0. 255, 255, 128, and 0. Is it? Yes. So change it into the binary. So 255, once again, 1, 1, 1, 1, 1. 128. Change it to get 1, 0, 0, and 0 is 0. So what we do next is we copy this, the binary for the IP address, put right here, and copy the binary for subnet mask, put right here. And what we do is we multiply the IP address binary of IP address and subnet mask. So whatever is multiplied with 1, once again we get the same answer. So copy this and paste right here. and whatever is 0 will become 0. So we copy this again and put right here, so we get 0. So and then we change it into decimal. So what we have is 10, 100, 101. This is become 0 and this is become 0. So that's just for the network address. So we got 10, 101, 0 and 0. Next one is for the backup address, broadcast address. So we copy this. Same after they multiply with 1, copy this and paste it back right here. And then fill the other with 1. Alright. So what we'll get is change them to decimal, and then we got 10, 101, this 64 plus with 32, 16, 8, 4, 2, and 1. We get 127. This is 25. So this is our broadcast address. So 10, 101, 127, and 255. So after get that, we need to stack the IPv4 address for the first host. So we need to take after the 0, so we get 1. So what we have is 10, 101, 0, and 1. So the IPv4 address of last host on the subnet, we will take 1 before the broadcast address. So what we get is 254. So we have here is 10, 101, 127, and 254. Okay, so for the problem 3, so the number of subnet bits, we need to find the prefix of the new subnet mask and minus it with the original subnet mask. So prefix for 225, 224, 255, and 24 is 19. So, oh, sorry. Okay, so 19 minus with 255, 255. So prefix is 16. So 16, and we get 3. So the number of subnet created is 2 to the power of the subnet bits, number of subnet bits we get before. So 2 to the power of 3, so we get 8. So for the number of host bits per subnet is 32 minus with the prefix of the new subnet mask, which is 19. So get is 13. So 13 right here. And for the number of hosts per subnet is 2, sorry, in bracket 2 to the power of 13, the number of host bit per subnet, we get 4, so 13, and then minus with 2. So we will have 13 minus with 2, we got 8190. So for the network address of the subnet, again, we go to this, clear the spot, this one, and put the IP address right here. So we have 172, 72, 22, 32, and 12. Alright. So change it onto the decimal. Got 72, 2, 3, 4, 5, 6, 7, 8. So 10. 1, 0, 1, 0, 1, 1, 0, 0, So next one is 22. 1 1 0 and 1 10 and this other is 0. Hope so. Next is 32. 1 2 3 4 5 6. So 6 is so 0 0, sorry, 0 1 and then 0 so 0. For 12, then we got 1 0 0 1 1. So 0, this is 0, this is 1 1, and then the other rest is 0. Okay, so then we need to put the new subnet mask into the 255, 255 and 224. Yeah, and change it into the binary. So this one. So for the 224, got 3, 4, 5, 6, 7, 8. So 0. So 0 is 0. Okay. So next is we copy this binary and put it right here. Copy the binary of subnet mask and put it right here. So once again we multiply. When we multiply with 1, we will get the same answer as the top. So just copy right here, paste it this, and same again as this, and paste it as 0 because anything multiplied with 0 we will get 0. So change it back into the decimal. So what we have it at 172 and 22. This one is 32 and this is 0. And so that's just our network address. So what we have, so we will write here 172 22 32 and 0. So next for the broadcast address, we just copy this until the last of the 1. We'll multiply it and we will get the same answer. And for the rest of the 0, which is right here, and we change it onto 1 like that. So we change it onto the decimal, so we get 172 22. For this one we have 32 plus 16 plus 8 plus 4 plus 2 plus 1, we get 63. This is 2255. And then we write back 172 22 63 22 63 and 255. For the IPv4 addresses of first host on the subnet, which again we take one after the network address. So it will be 172.22.32.1. For the IPv4 address of last host on the subnet, we will take one less than the broadcast address. So we get 172.22.63.254. So that's for the problem 3. Okay, next for the problem 4. For the number of subnet bits, we need to find the prefix for the new subnet mask. So, and minus it with the prefix of original subnet mask. So for the prefix of new subnet mask is 30. So that's 30 and minus with 25 is 24. And then equal to 6. So this is on 6. So the number of subnets created, what we need to do is 2 to the power of the number of subnet bits, which we get 6. So 6. Okay, bracket, and then minus, oh no, so we get 2 to the power of 6, 64. So that's for the number of subnets created. For the number of host bit per subnet, what we need to do is 32 minus with the prefix of the new subnet mask. So have here is 30. So 32 minus with 30, so we get 2. So that's the number of hosts bit per subnet. For next one, the number of hosts per subnet, what we need to do is in bracket 2 to the power of the number of hosts bit per subnet, which is 2, and then minus it with 2, which is the network address and broadcast network broadcast address, and then it's equal to 2 to power 2 is 4, 4 minus 2 is 2. So that's the answer for the number of hosts per subnet. So for the network address of this subnet, need to see the host IP address and put it on this right here. Clear this one first. So we have 192.168, 192.168, 1 and 245, 1, 2, 4, 5, and then we need to change it onto binary. So 192, got 1, 2, 3, 4, 5, 6, 7, 8. So 1, 1, 0, 0, 0, 168, 2, 3, 4, 5, 6, 7, 8. 1, 0, 1, 0, 1, 0, 0, 0. And this one, right? 0, 0, and 1. So for 2, 4, 5, you get 1, 2, 3, 4, 5, 6, 8. So 2, 3, 4, 1, 2, 1, 2. Next, we need to put the subnet mask, new subnet mask. So 255, 255, 252, 255, 255, 255, and 252. Okay, and change it onto the binary. Two five two 0, 0, 0, 0. Okay. So what we need to do next is just copy this, the binary of IP address. Just put it here. Copy the binary of subnet mask and put it right here. So what we need to do is everything that multiply with 1, we will get the same answer as top. So we just copy this. And then multiply with 0 and we will get 0 and 0. So what we need to do next is change this binary onto decimal. So what we have here is 192.255, no, 168, 1, and this one's 128 plus with 64 plus with 32 plus with 16 plus with 4. So we get 244. So this is our network address. Two, 168, 1, and 244. Next, we need to find the broadcast address. So same again as the top. We take until the anything that multiply with 1. We take it and you put right here. And then for the rest of it, you just put 1. The last one. So change it to decimal. 192.168.1, then 244. It's 244 plus with 2 and plus with 1. So we get 247 right here. So 192.168.1 and 247. So for the IPv4 address first host, we need to take one after the 244. So we get 192.168.1 and 245. For the IP address of last host, we need to take one before the 247. So it's going to be 192.168.1 and 246. Okay. Okay, next for the problem 5. For the number of subnet bits, we need to find the prefix for the new subnet mask. So 255, 255. 5 is 24. So 24 minus with the 255, 00, 00, which is 16. So 24 minus 16 with 16 will equal to 8. So for the number of subnets created, so it's just 2 to the power of this one. So 2 to the power of 8, and we will get 2 to the power of 8, and then 256. So for the number of host bit per subnet, so 1 is just 32 minus with the prefix of the new subnet mask, which is 24. 24, and we will get same also 8. So for the number of hosts per subnet, what we need to do, we just need a needs a bracket. So 2 to the power of the number of hosts bit per subnet, which is 8. So 8 and close bracket minus with 2, and we will get 2 to the power of 8 minus with 2 is 254. Okay, so for the network address, so we need to copy this host IP address and place it on here. Let me clear first. So 128.107.0 and 55. So we need to change it onto binary. So 128 get 1, 2, 3, 4, 5, 6, 7, 8. So 11000 for 107. There we get 1, 2, 3, 4, 5, 6, 7, 8. So 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1. So 0 is 0 for 55. Okay. 2, 3, 4, 5, 6, 7. So 0, 0, 1, 1, 0, 1, 1, 1. Okay, so now we need to fill in our subnet mask. Subnet mask is 255, 255, 255. So 255, 255, 255, and 0. Yes. So fill in the binary. And 0 is 0. Okay, then we need to copy this, the binary of the IP address. Copy and paste it right here. Copy this and paste it right here. Okay, next we need to multiply both of the binary. So everything that multiply with 1 will get the same answer as top. So just paste it right here. and the other is 0, so we get 0. So then when we have this, we need to convert this into the decimal. So 1.6.128.107, will be 0 and this will be 0. So this is our network address. So 128.107.0.0. Yes. So for the broadcast, so we just need to copy again. The only thing that multiply by 1, we get the same answer. So we just copy and paste it back. And for the rest of this, just fill it with 1. So this is converted back to the decimal. So we get 128.107. This will be 0 and this will be 255. Just copy this and put on the paper. 128.107. 0 and 255. So for the IPv4 address for the first host, now we just take the one after the last of the network address subnet. So we get 128.107.0.1. So for the IP address of last host of the subnet, we will take one after before the 255. So it will be 128.107.0.254. So that's just for the problem 5. Okay, so to the next problem. So to find the number of subnet bits, to find the prefix of the new subnet mask and minus the original subnet mask. So for the prefix of new subnet mask is 248 to 29. So 29 minus with 255 is 24. It's 24. Then equal it to get 5. So that's the number of subnet bits. So for the number of subnets created is 2 to the power of the number of subnet bits, which is 5. So it's equal to 0.5 is 32. So for the number of host bit per subnet, need to 32 is minus with the prefix of the new subnet mask, so which is 29, and we will get 3. Number of hosts per subnet, so need to do is do a bracket 2 to the power of the number of host bit per subnet, which is 3, and then minus it with 2. So we will get 3 minus with 2. So the answer is 6. For the network address of the subnet, we need to copy the host IP address. So go to this, clear this one, this 2. So need to put this now 135.250.180. So need to convert it into binary. 2, so 11, so 1, 1, 0, 0, 0, 0, 0, 135, 2, 3, 4, 5, 6, 7, 8. So 1, this is 1, 1, 1. This next 250. 2, 3, 4, 5, 6, 7, 8. This 1, 1, 0, 1, 0. And for 180, 1, 0, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 0, 1, 1. 0, 1, 0, 0. Next, the subnet mask. Subnet mask is 255.5248. So 255, 255, 255, 248. So this one, oops, 248 is 1111. So 2, 3, 4, 5. 1, 2, 3, 4, 5, and 0, 0, 0. Okay. So what we need to do next is copy this binary and paste it on here. Oops. Paste it here. Copy this one and paste it right here. And then we need to multiply the binary of IP address with subnet mask, and know that if we multiply with 1, we get the same answer. So just copy this and paste it right here, and then copy this and paste it right here. So what we have is the binary of network address, and now we need to convert it into decimal. So this will be 912, this will be 135, this is 250, this one is 128, got 128 plus with 32 plus with 16, and so answer is 176. So and then paste it back right here, 192, 135, 250, and 176. Then onto this, we copy until this one. Now we copy onto this one. Paste it back right here. And then we fill in the gap with 1. Then we convert it into decimal. So we get this 192, 135, 250. Then this one is, they had to add 4 plus 2 plus 1. So we got what? 8183. So it will be 192, 135, 250, and 183. So for the IPv4 address for the first host, we need to take 1 after the 176. So it will be 192.135, 250, and 177. For the IPv4 address of the last host, we need to take 1 before 183. So it will be 192.135.250.182. So the last question is, why is the subnet mask so important when analyzing IPv4 address? So the answer is that subnet mask means everything about the address, the network, the number of host bit, the number of hosts, and also the number of broadcast address. So that's all. Thank you.